So my name is Pedro Garcia. Most of you already know me. So I'm owning SystemReady Devicetree within the architectural technology group in ARM. Basically today, as I'm doing every single year, I'll be presenting what is the roadmap ahead of that. So I'm not going to go very much into the technical details of how, what, and why. Well, the why, yes, actually, but not how. So yeah, so let's go. So I don't have to explain what SystemReady is actually, but just in case. So within this kind of these aspiring software just work, actually we know that software just work is a very challenging thing. Actually, that's our vision. But actually, the mission is just to provide this off-the-shelf interoperability between the OSs and the platform, right? So that's much more tangible thing to handle. This is what we have done over the years. So this is kind of the historical roadmap, if you like. Actually, that's where when we started back in 2020 with the first release of the IR, it was kind of a 1.0. At that time, so we start with laying the foundations of what SystemReady was supposed to be. Actually, just kind of defining the EVVR, providing kind of tools around the ACS, the certification scheme, and so on and so forth. Actually, that was the beginning, actually, and just laying the foundations. On the second release on 2022, actually, so we aim for correctness of those fundamental capabilities we were laying on the first version. Because as an example, where on the first version we were just working with capsule updates, as an example for firmware update, wasn't correct. And what I mean that wasn't correct is that we were missing things like ESRT, we were missing kind of a GUID, so on and so forth. So then what we were aiming for this second release is for the correctness of those fundamental capabilities we were just testing on the ACS. And finally, on 2024, last year, so we released the 3.0, and that's where we were aiming at that point. It was completeness, and it's completeness around specific and actually what we thought that could be kind of what SystemReady value proposition is, and it was supposed to be delivering, which is boot level readiness, kind of a maintenance level readiness and security level readiness. Actually, so the idea was just to make sure that at that point we could deliver the value proposition through booting, maintenance, and security, right? So that's what we did last year, actually, and now we are thinking out, okay, what's next? So then what we are thinking is about how we kind of transition to a model where we can grow, we can scale, and then is how we can, so it's what happened after this MVP version, actually, what happens after these boot capabilities, maintenance, and security, what's next, actually, what we can do next. And that's where I'm going to be focusing this presentation, actually, on this, how we scale up. Actually, you know that, actually, we are pivoting from certifications to compliance, and then these, what are the new kind of capabilities to satisfy specific use cases and industry demands. Well, a model that scales, so that's said, so it's something that the motivation of that is just pivoting from certifications to compliance. The reason for this is because we have to look for a way that this is sustainable and scalable. As you know, certifications within ARM, so we were, the way we were doing is we were working closely with all the partners just to do the certifications. And we could do that with a number of platforms, a number of vendors. This is something we can do, we cannot do for hundreds, right? So then what we said is we have to migrate. Now we have a very mature set of specs, mature set of toolings, how we grow from here, actually the point. And the challenge we were facing is that the tools, if you have been working with ACS, with SystemReady, so the tools were very much designed to be used by a certification team. So that means that you have to have very knowledgeable, you have to be very familiar with the tools, you have to be very, so you have to know quite a lot reading the logs, actually. I think SystemReady, the ACS is in the range of 8,900 tests, something like that. So then if you have to read and understand every single log, it's mission impossible. Actually, that's very challenging. Actually, so then the challenge is that how we made that accessible to everyone, actually, and then not the certification team from ARM could do that, actually. So then the different phases we approached is on this very first phase, it's kind of what we call that kind of autonomous testing. Actually, it's kind of reduce the level of human interpretation reading out the logs. Actually, then you have the output of ACS is much more comprehensive or much more readable, human-readable format, where somehow you say that if you are complying or you are not complying upon a given number of configurations, actually. So then you don't have to read 10,000 logs and trying to understand what they really mean. So that was delivered November 24 last year. So then what we have released now in April 2025 is this phase 2, which is semi-automated testing. So that means that we have gone a bit further, and actually, and there's the manual intervention is less. So that means that originally you had to integrate from 3 different repos. You have to integrate that in order to run it. Now you don't have to integrate 3 different repos. Everything is on a single image. It's much more integrated, actually. So now you have configuration files, you have waiver files. Actually, is much more automated. Actually, now it's much more accessible, much more CI/CD friendly, so much more accessible to everyone, actually. And on the phase 3, actually, is something we have not committed date. Actually, the plan is just to have kind of a suitable for general use. Actually, anyone can use it, actually, but that implies documentation or information is far better, actually. So the out-of-the-box texting has to be pristine, so on and so forth. But this is something that we are not planning just to do any release of this in the near terms or in the coming year. So that's why actually working with partners like Linaro, OneLab is vital, it's fundamental, it's instrumental, because actually this is something, like I said, for us, so we are not supposed just to work with partners, just to how we do that for your platforms. Actually, we have to work with partners like OneLab, with Linaro, just to make that happen, actually, and support how to make your platforms system-ready compliant. Okay, so that's the second part, actually. So the initial part is kind of make the transition to a model that scales. Now it's more about grow in terms of capabilities, as I said early on. So we were working on this boot, maintenance, and security. So this is what's next. But before we go into next one, actually, we have to. That's probably the only thing we are missing for this MVP or from this kind of value proposition delivery from SystemReady. So I think that we have done pretty much everything for boot readiness, security readiness, but what we are missing is on this maintenance readiness is the AV support. This is something we are still missing, and we are working with Linaro. Actually, we are working with a few other partners. If you are part of SystemReady, you will be familiar with that. Actually, we are working with Red Hat, with so Red Hat is kind of Richard Hughes. He's maintaining LBFS and firmware update. Actually, he's supporting us what needs to happen in terms of specs in order to support AV. And the main problem with that is AV is not described or is not supported within UFI, and this is a bit of a problem. So we are describing is, do we need a ESRT version 2 table for this, or how we do that, all that stuff. So that's why it's taking so long, right? But I would say this is the only bit missing, just to achieve or complete kind of the full value proposition from SystemReady at this most fundamental level. In terms of edge IoT capabilities, beyond booting, maintenance, and security, that's where it comes the tricky bit, actually. The point is we could be discussing many different capabilities or use cases. Actually, one thing which is very common and everyone is talking about is device onboarding, FIDO, and digital trust, all those sort of things. The problem with that is that if you look at this from a generic perspective, the problem itself is not on the edge device. The problem in this is on the infrastructure. You have to have things like the rendezvous servers, the attestation. Where is that? So then the limitation is not that the edge device or the protocol itself, it's just putting in practice is really, really challenging because the infrastructure. So now what do we do? Actually, just sit and wait. Well, the answer is that there are specific use cases for onboarding, as an example, where you can constrain and you can think that where the infrastructure could not be a limiting factor. And this is what we have been discussing, where if you are thinking on, I said, device onboarding or whatever, if you are not thinking from a generic perspective and you are thinking on-premises computing architecture, so you kind of somehow you narrow down and you get rid of all the complexity of the infrastructure, because in that perspective, You have your IoT devices, which are working with on-premises. They are very well connected to our edge server, connected to the DevOps team, so on and so forth. And actually, then obviously you have kind of on the remote side, you have your servers, your analysts, or all that stuff. So this is making life much simpler, actually, and adoption can be much more realistic, actually, and that could be kind of a very much more actually the path of less resistance in order just to get new standards or new specs around how we could do onboarding without making the infrastructure a limitation factor, right? So then if we look at this, something like that, I said that this is something that if you look at on-prem computing architecture, that can be applicable to industrial, robotics, can be retail, you name it. Actually, there are many different use cases or market segments where you are going to be facing IoT devices connected to a server, actually, and obviously the server actually is going to be providing the services for onboarding services, as an example, for the edge. So then the number of capabilities we are looking at within this constraint, where I said the infrastructure around the services is not going to be a problem, or actually going to be a very minor problem or not a gating problem, is thing around fleet management, as an example. So where we are thinking about obviously, we know that all the IoT devices must be onboarded. So actually, in some occasion, maybe you want to deploy them with a completely new OS. They have to be maintained, so on and so forth, actually. And then very much kind of a service-oriented architecture capabilities, like actually kind of virtualization, containerization, or multi-tenancy. And also, I'm just introducing Android and Linux UI. Actually, Android is, if you're looking into points of sales, as an example, so Android is just moving in that space. So that's kind of interesting, right? So those are the sort of capabilities we are looking at from SystemReady. But before I continue, actually, because we have had this discussion with a few of you, actually, and that sounds like the scope of SystemReady is growing very much, actually, and SystemReady is not the vehicle to drive device onboarding and so on and so forth, actually. The answer, or kind of the reminder, is obviously we are not trying to solve from SystemReady device onboarding, attestations, and all that sort of things. Actually, what we have to be mindful is the scope of SystemReady basically is agree and define the interfaces between the platform and the OSs. Actually, whenever you see that, I'm defining, if you look this dash line there, this is what I call the interoperability line. Whenever your data is crossing that line, that means that you have flow of data from the OS to the firmware, to the hardware, from the application to the firmware, or whatever. If you are crossing that line, that means that you have to have an interface. You have to have some sort of a service call, a data structure. You have to have that. So then, if whatever we are talking about, virtualization, whatever we are talking about, device onboarding, whatever, zero trust, or whatever, if you have a need to cross information from the OS or from the upper layer to the down layer, this is the scope of SystemReady. Actually, what we are defining is the interfaces between that. So I said, our aim is not to solve onboarding, because onboarding is going to happen somewhere above, in some areas, somewhere below. But as soon as there are exchange of information between the OS and the platform, we have to provide the interfaces. If those interfaces are already available by UEFI, that's great. If they are not, we probably have to create a new spec, or we have to define a ways of that, how the OS is just calling in services into the platform. Okay, so then the gap analysis, just going back to the diagram, the on-prem compute architecture, the things we think that we can tackle, at least at the investigation level for the coming years, is the intersection, as an example, with Android. So we know that Android, at least for that specific market, so they are kind of embracing and engaging with UEFI. I think this is a really good opportunity, actually, just to understand a bit more, actually, what this GBL from Android actually. So what are the commonalities with UEFI and the extensions beyond UEFI, and to what extent this Android GBL could become kind of SystemReady compliant. If that would be the case, actually, that would be really good, actually, because at the end of the day, you could see that the same code base or the same platform can land either Linux or Android with no code switching. So that could be really ideal. Virtualization, again, so workload portability. In that scenario we were seeing before, it is quite common actually, you're thinking that you have to repurpose your devices, or you have to just reshape workloads. You have to have virtualization. You don't want just to every single device working on a different manner. So that means that all your devices has to be kind of a Kubernetes-like, or kind of a virtualization-like friendly. So that's something that that's the idea behind that. And then again, every morning, so this morning we already heard about EU CRA, so then security is important, is paramount. So then how you do the onboarding without talking about FIDO, without talking about any other protocol. The thing is that if you're thinking about early onboarding, at some point you have to deploy the keys, and you have to do all that stuff. Actually, then how you establish a kind of a secure session with between your edge device to a server, this is something we are kind of starting to look at, kind of the key provisioning for that. Obviously thinking on the EU CRA and so on and so forth. Excellent. Those are kind of things we are kind of discussing with the system RTC. We're also just discussing internally initially. So we are kind of in kind of investigation, so kicking off the topics. But actually, that in the coming weeks, months, actually, we will start just engaging on the system RTC for much more in-depth conversations in that. So as I said, if you are not part of the system RTC, you are more than welcome to join, actually, because this is open to anyone. Actually, those are things that you are interested in attending, so you are more than happy just to come. And finally, something which is fairly new is kind of the previous one's Edge IoT. So this is automotive capabilities. This is fairly new, and the intent behind that is that well, so there's a high demand actually when you have kind of a hardware safety, and basically you know that we have a need, or there is a need within automotive capabilities actually, yes, to have that if the thing is not working, you have to know it actually, and you have to interrogate your platform. So then there has to be a way of detecting these permanent faults actually, and then the way of detecting those permanent faults is by means of kind of a test running on the EL3 or running by ear on the hardware. So then the software has to have a way of scheduling the runtimes of those tests happening on the EL3, define which tests to be run and when actually, and then if they detect the faults, they have to decide what I do. Actually, do I stop the car? Shall I go? Actually, what is the criticality of all that stuff? So then the OS has to make that decision. So then the scope of SystemReady, again, as I said, is not to define how all that stuff is going to be doing. Actually, what we have to be doing is defining the interfaces on how the OS can interface to the platform in order just to, as I said, to schedule the runtime tests, actually how can do define what test runs, and actually then make a decision what to do with that. Actually, as I said, this is the new firmware interface, which is something we are currently working. Today is available through, it's kind of confidential actually, but it's going to be a public version in June 2025. And again, actually, so this is something that you need more information about that. Actually, so the owner of that initiative is Bertrand. Actually, Bertrand is there. So, so you can just get in touch with him. Actually, he will more than happy just to discuss with you guys in terms of what are we doing in that regards. And finally, so kind of this is kind of a summary. Actually, I don't expect you to read all that stuff, but it's kind of all the things we have been doing since 2024. And actually, I like to split that into kind of different swim lanes in what we have done in terms of a structure. This is the infrastructure of ACS, the pivot to compliance, actually things we have done in terms of the boot and installation capabilities. So things around, yeah, so well, you can see that actually, but maintenance, security, and now we have a new swim lane, which is the fault detection capabilities, if you like, for this. And 2026, you can see basically what we have discussed so far. Actually, is where you can see the GBL investigations and the kind of type 1 hypervisors, actually, and then a few other bits and pieces. Actually, but this is basically what we are kind of heading towards in the coming years. And I think that's it. Actually, unless you have a question, anything you want to know more, bless. There's a question there. Yep. So wait a second, I'll give you the microphone. If you
can go back a bit on the slide 11, there is an interface between, okay, here.
Yeah.
You mentioned that whatever crosses that boundary between the OS and the firmware should go to SystemReady. And I guess that not all the services will go through this. I mean, I do expect that only the boot services and not the rest of the services, like, I don't know, I can think about accelerators or anything else.
Well, it depends. It depends, actually. If not really, actually, drivers. Actually, if you're thinking about Devicetree, it's not only about booting. Actually, it's more than booting. Actually, if you have a graph, every node on your Devicetree, if that node in your Devicetree is supposed to be visible and accessible from the OS, actually, we have an obligation to provide integrity checks for this node. So if you have a GPU or a graphic things, actually, you have to make sure that this driver is properly linked to a node. Actually, it's been loaded, it's been initialized, actually, and it is there. We are not going to check the performance of the GPU. We are going to check that it is working perfectly well. But what we have to make sure is that if your platform is describing on your Devicetree that you have a GPU, you have a graphic device, so the OS truly has access to this. Actually, it's not only booting. It's actually what you are exposing from your platform upwards needs to be good. Actually, it needs to be ready to be used. We are not going to check performance. We are not going to check quality, because this is kind of the competitive advantage of everyone, actually. So then everyone has to decide its own level of performance, quality, and so on and so forth. But in the other way around as well. So if the OS has to have access to any service on the platform, that's it. TPMs, as an example, in terms of security, you don't really need a TPM for this. But actually, yeah. So the OS has to access. So then you have to have a driver for the TPM, how to reach the TPM, maybe through the secure walls. Actually, you have to go through the OPTI or whatever. But that's something that, yeah. So that's a plan. Not only booting, maintenance, and security. So it's just making sure that whatever goes across, it's properly defined. The example is automotive, actually.
Okay, in the TPM case, let's assume we have this example. Let's assume that the TPM has a firmware, built-in firmware into it. The interface between the OS and that firmware, should it go through SystemReady?
Well, that's that. Yeah. So we have the BBSR. The BBSR spec is the base boot security requirements. Actually, that spec is defining how these modules are, how those components are supposed to be communicated between the OS and the platform. Yeah. Yeah.
Okay.
It does.
Thank you very much.
Yeah.
So with respect to system-ready scope of work in the future, so things like firmware initializes devices, for example, FI or any particular device, when it hands over to the operating system, lots of these things are reinitialized. So there's a lots of waste of time that operating system is doing, which already firmware did it. So are there any requirements in the scope for future system-ready thing to take care of such things like handoff, resources handoff from firmware to operating system?
So we have to see the use cases of that. Actually, if we are kind of a services, actually we already have handoff of services. Actually, when you are doing the handoff or you are doing kind of an exit, you play the exit service actually from one to the other. Things like your capsule update, actually this is something you are handing over. Actually, this is happening on the runtime. Actually. Yeah. And this is something which is today is very well defined by UFI. Normally UFI is the baseline, and whatever the services we are looking at in UFI is what we are looking at. But that doesn't mean at some point we discover we find different services which are not described within UFI. And that could happen with early onboarding, with digital trust, that could happen with that. If at some point we see the use cases, why not? That is something we could happen.
Use cases are there. It's just that, I don't know, because the firmware actually spends decent amount of time. We're talking some couple of milliseconds to do stuff. And the OS repeats the same stuff. That means you're actually wasting time of the operating system to do the same thing which already firmware did. So that's again, I think that the problem is there. I don't know if it was never thought or it was never considered, but the problem is still there.
Well, I don't have an answer to that. I don't know. Well, so we have experts here within how things are done. Actually, I don't know if Vincent or Elias actually they have an answer.
I wasn't around the meeting and I lost the question.
So, so the question was, the firmware initializes stuff like, for example, PHY itself. Let's take an example, USB 5. It initializes the 5, it does lots of analog stuff, and then when it hands over to the OS, it just ignores that, and OS will just doesn't trust the firmware at all, and it will start initializing everything. So my question was more of, what is SystemReady scope in this for the future? Is it going to consider anything such like that?
I don't think there's anything. This is an OS decision, right? And it's not always like that. For example, Linux sometimes relies on the fact that the firmware has initialized some bits, and if you don't have that, some drivers don't even work.
Linux doesn't trust anything firmware does.
So there's no provisioning within the EFI specification, which is what SystemReady is trying to address, that you have a list of drivers that you tell the OS, I've done my job on this, don't touch those drivers. There's no concept we can piggyback to expose that from SystemReady.
So,
but in a case where you would like to establish SystemReady as a way to say that you can run any generic OS on top of this platform, it would make sense to actually document whatever the bootloader did, so that the OS would know.
So that's why somehow the initial principle is just to define very clearly what is the function of the firmware and what is the function of the OS, and not try just to change or move functions that traditionally were on the firmware to the OS, because that would be very messy. And actually,
they need a standardization.
That's the point. Actually, very clearly define what are the functions to be executed from the firmware side, what are the functions. Actually, then you are setting the expectations. That's a bit the point. Wasn't like that a few years ago, actually, where you could see that some of the functions where you could find them either on the platform side or on the OS side, actually, and then is where the whole thing becomes very, very messy. What we're trying to do, actually, is that, okay, so that sits within U-boot or within the firmware side, and that sits within the OS and should stay like this, actually, yeah, that's the point.
Thank you.
Or should be like this. Okay, I think that's time. Thanks a lot, guys. So, any questions? Me, Bertrand, Vincent is there. Thank you.